first I'll explain you, and there are large number of features, how to identify best features. That's the first thing what we are going to see now. And in this scenario where we took a data set and many features are actually being available, but none of the feature combination is actually helping me. So what I can find is I can select some the best features. So the best features I can actually first take out, and for that the best features I can apply polynomial regression. Right, in the yesterday's assumption of linear regression, I said on right the control function. Right, it is not that y is equal to mx plus c is actually one of the only equation for linear regression. We can also have a polynomial. We can have like y is equal to beta naught plus beta 1 x1 plus beta 1 beta 2 x squared. We can also have those polynomial degrees. So first I need to identify the best parameters, and from that the best parameters I can apply something called as polynomial regression. Right. So the first part is identifying the best parameters. First we will do that. Yes, for that the code is very simple, right? I'm taking that this is my x train value and this is my y train and x test. Up to this you itself will have. Now what I'm going to find is I'm going to add another package over here, that is sklearn.feature selection import f regression. Right, this is actually the parameter I have taken next. Next sklearn.feature selection import select k best features. Right, so this is actually the two packages I have added new. This is from sklearn.features underscore selection import say select k best, and from sklearn.feature underscore selection import f regression, f underscore regression. So what is the thing is I'm going to calculate f score for each of the best features. Right, I have given here totally 5 features. See, this is x is the data 5, 50, innings, average, range descending, and IHS. And for these 5 features, I can calculate which is the best one. So what I can do is I can just call the function select features, and this select features function will get data from this particular data what I'm giving. For example, I'm having my x train data available, y train data available, and x test data is available. Right, y test is not needed. Why? Because y test we will not generally show to my model. My model will not know what is y test, but this y train will be known. Why? Because using this only it will identify what is the error. Right. So now I'm just saying that's just to create fs dot scores. Fs dot scores underscore will give you the f score for each particular parameter that is actually coming out. Right, so I take 5 parameters, and those 5 parameters I'm taking and then printing that f score, and then I'm also plotting that f score by using this particular code. So this is the plotting ways. What in what approach I started is I actually took all the parameters available. I took all the parameters available. Just I take everything. Name is actually a categorical. I don't take that. Span I should be in a year term, or the experience can also be measured from number of matches or mostly innings. So these three are actually somewhat more closer, because number of matches played will be more or less equal. Is more evident than number of innings. So both are actually same, somewhat same. So I take from number of innings, not outs, run descending, highest score, average, best figure. Strike rate is not needed because that is the output variable. Hundreds, fifties, and zeros. All the parameters I take, I come to my model. I substitute to my input data. I substitute all to my input data. Right. This strike rate I will take it off because this is an output variable. Yes, this is what I did now. So I took all possible inputs. From this possible inputs, what I have to do is I should take the what is which variable is actually contributing more to the output strike rate. So I have to analyze that. So when I do that, I run this. If you see, all the f score values are actually being printed. See, all the f score values are being printed. For feature 3, feature 4, until it is maximum. So go to the top and see what is feature 3 and feature 4 and all. So it starts from 0. So what if from 0 you have to count. So innings is the 0th feature, not out is 1, rest listening is 2, highest score is the 3rd feature, average is the 4th feature. So 3 and 4 is having more F scores. Next 3, 4 is there. Next I find next maximum is feature 6. This can be better visualized well in the plot. You see, feature 3, feature 4, and feature 6 are actually contributing more. Right? You can take all the three, or you can take any two, and then you can actually continue with the regression model. And if you see the variance here, when you take all the parameters, this is actually the variance 0.36. Somewhat a better variance is obtained, but we cannot take all the variables for performing this particular regression, because we need time also to be managed. But this curve is comparatively better than the curves what we obtained before, right? So this is actually better. But let us also try for another method. What is that is, the best among the three is these first one is highest score, average, and the sixth one is best figure, right? So those things alone I take, and using those things, I let me do some analysis. For example, on highest score, average, and hundreds, I hope 0, 1, 2, 3, 4, 5, 6. So highest score, average, and hundreds alone I take, and those for those things I can actually do some analysis, right? So far so good. What I'm actually doing, am I making it clear? Just working on with trial and error basis. Am I making it clear?
Yes, sir.
Yes. So my next step is, I'll remove those which are actually not that much useful. I remove what are the useful features? 0, 1, 2. This is the third feature which is useful. Fourth feature which is useful. Sixth feature which is useful. Just I take those things. It is actually being a try. It is not that it will give me highest variance and all. Just a try what we are actually doing. So these three features I take: highest score, average, and 100. We'll run this again. And if you see here, the variance is actually decreased. Why? Because these three is alone not efficiently contributing to the output, and the curve is also not that much good. It is scattered somewhat, but it is not looking good, right? So, and ultimate, what I think is, these curves, by being normally, they cannot contribute efficiently to the output. So what I have to go is, I was actually pulled to the position that I need to go for complex equations, because there is no other way, right? Like Shirdi got 0.12, and when I do all the things together, I got 0.38, and when I take the best features alone, it is only 0.08, and even more best when I take 50, it will be maybe even more best. So it is not reaching more than 0.12, and I cannot take all the features together also. So what is the next step is, we can go for polynomial regression. Very simple. What is polynomial regression is, take the best features, increase the degree of those features. For example, if it is Hs, it will be like beta 1 Hs. Why it should be beta 1 Hs? We can make beta 1 Hs plus beta 2 Hs the whole square. Why not we make that? If we make that, surely it will give some good impact. We can actually try that. Similarly, this if it is 100, if it is beta 300, why can it be beta 300 squared? So those things also we can try. That is actually called as polynomial regression, right? Before going to that polynomial regression, I want you guys to try this F score also, right? Hope everyone have this, right? The previous code. Just include this F score value also. This is actually the curve. So this code actually you have to utilize, right? After the extent, you just apply the feature selection and see which is the best feature. Because we tried almost all the features, we selected F score also. That is also not working. So then it should be going to polynomial. See, in the end def select underscore features function, I'm having fs is equal to select k best of score function is equal to f regression. Right? F regression is also we have the package ready, and k is equal to all, mean that I need to take all the parameters and weights. Next, fs dot fit of x train comma y train, and x train underscore fs is equal to fs dot transform. That is calculating f score for x train, calculating f score for x test, and then I return all. This is actually the feature selection code definition. So the ultimate what here is, if you understand the code, what kind of data set comes over here. Just you can apply the same code, can either tend to be linear regression or multiple linear regression, or you can select the features, or you can also go for polynomial regression. Everything stands out over here only. So you need so data set is also not downloaded from net. Code is also not like that. Data set you actually scrap. The code also we know that what is the base of each of the thing. Now we are going to estimate the R squared value. That is R is nothing but coefficient of correlation. Now we are going to find R squared, that is coefficient of determination, which is nothing but how many points are actually very close to percentage of points closer to the regression line. If more number of points are closer, it is good, right? That only we are going to find the next. I tried actually with different kind of things, and I found that surely it is not raising the variance more than 0.38. At any point of time, I couldn't get variance equal to 1. I think that it is not at all possible. So only I went for polynomial regression. So now I proceed to the next thing. I just take the same code again. I just copy the entire same code. I go to the new tab of code and I paste everything here. Right. So the thing what I'm going to do that I understand that my code is not going to work for any kind of features here. This features is actually not working for me, right? So what I can actually do is I can select features which is actually having most number of coefficient values. That is nothing but highest score, average, and 100. It is before the linear regression start. I'm taking here another thing that is say poly underscore regression. So this polynomial underscore regression is going to be taken for increasing the degree, right? So I take polynomial features. This polynomial is nothing but I'm increasing the powers. Instead of being mx plus c, I'm saying mx plus mx squared plus mx cube, like that. I'm taking the polynomial features also to be available. And before going for the polynomial features, it is required to import the package also. Okay, I'll go to up from scale dot pre-processing. So before going for my regression, I make it polynomial, my variables. Okay, let a pre-processing import polynomial features. So this thing I import from SQL under pre-processing, import polynomial features. And when I do for the polynomial features here, it will ask me what is the degree you want, degree of polynomial you want to use. It will ask me that particular statement. Usually by default, the degree is equal to 1, meaning that it is linear. And I can also increase the degree. Let me make it degree equal to 2. That is now it is not just HS beta 1 HS. HS is highest score. It is not now beta 1 HS alone. It is beta 1 HS plus beta 2 HS the whole square. That is also considered. Okay. Next, what I can do is now the thing is available. Now I need to fit the training examples with respect to that. So I take the training values. Let me do it for the entire kind of variables. So I say poly underscore regression dot fit underscore transform of x. So I'll move this since I'm not doing it only for training, I'm doing for the entire data set. So I'll put this on top of the training data. I'll go on top of the training data and I'll put before training and testing is going to be splitted itself. I'm going to do this, right? So this is actually ready now. Now after having this, I can actually continue. Now I can increase the degree. Whereas now degree is actually is being 2, right? Previously, if I found that the points are actually, we will see how the points are actually looking out here. If you see that this is actually the points when you have a normal linear regression. Now I increase the degree equal to 2. Now let us see how the points are going to vary now. Let me see something has happened. Poly underscore regression dot fit underscore transform, not transform, spelling mistake. Transform. Yes. Now, if you see, the points are somewhat better, but I was not still satisfied with this. I made a degree equal to 2, but still I'm not satisfied with the points, right? So what I have to do, let me also say you one more thing. The number of points closer to the regression line is actually they are denoted by the R squared value. Yes. Now we know so that what is R squared value? R squared says number of points actually closer to the regression line. We know that R squared should be as closest to 1. R squared should be 1. Right. Let us see. Let us also calculate the R squared value and then see how when I increase the degree, how it is actually moving, the R squared value is changing. That will be very nice. So I add another thing here. So since Yugandhar came to come here, let me add this also. From sklearn dot metrics import R squared. R squared. So sklearn dot metrics import R2 square. Right. So this I add, and I also calculate here. We calculate actually coefficient and variance. Along with the coefficient and variance, let us also calculate R2 R squared estimate, R2 score, and we can calculate R2 score with respect to the y train value actually. So the y train is nothing but the output which I showed to my model, and I can with respect to the y train, I need to say what is the predicted y value. So y underscore train is the actual y value. So let me put the function also, R2 underscore score, R2 underscore score y train, that is the actual y value, comma, what is the predicted y value. Predicted y value is nothing but linear regression dot predict, linear regression dot predict of x train, x underscore train. So this is this entire term is predicted y value, and this is actual y value. Using this, it can actually identify what is the residual error and calculate the R2 square, right? So with this, let me run the code for degree 2 itself. I'm not changing the degree. The same degree we are running, and we can check the R2 squared value also. R squared value also here. And see here, R squared is only 0.07. It is very low, closer to 0. I will not say this is worst, acceptable, right? But not that much good. So let us go up and try to increase the degree, right? Let me go up and try to increase the degree. So I'll change the degree from degree equal to 2 to now 3 degree. That is cubic values also, more complex. So let me come down and see. So what is the R2 square? R2 score is 0.08, slightly increased. Now points are actually coming as close as possible here, right? So, but still not satisfied. Many points are actually more far from the regression line. This is the regression line. It is more far. So let me actually increase the degree further. Actually, increasing the degree is not a very good thing, but we don't have any other choice, so we go for polynomial regression. And now we make it to degree 4. Now, if you see, when I increase the number of degrees, the number of features are also increasing, right? So now you see, R square is increased to 0.1, and if you see how close all the points actually came, that much number of features I actually took, and it is actually giving this much thing, right? And variance also came -1. It means that something increases, this decreases, and in variance became -1, right? So somewhat good also, right? So but it is extremely complex, but I'm getting somewhat good results. See how close all the points are actually. So this is actually the thing called as polynomial regression. When you go that none of the features individually is actually satisfying your output requirement, then you go for polynomial regression. So when I increase the number of features is also increasing. See. Here also you can make some dropouts depending upon the thing, but the weights are actually even more less also. Only for some values the weights are higher. For others weights is very low here. But extremely complex equation it is. Right now you can add these two lines here. Add these two lines. Poly regression is equal to polynomial features. But understand that whenever I ask you to do a linear regression program or multiple linear regression program, you need to have this polynomial regression. No, it is not like that. Only when the features are not supporting you, you do this. And when you go for the lab manual and run right also, you just to show how the linear regression is doing and how multiple features is actually giving the plot. And then go for changing the features, adding the features, finding the best features using the k best feature selection. Finally, come for polynomial feature selection and then polynomial regression. Okay. Yes. This is polynomial regression plot, and R2 square is also on the bottom. Yes. This is for polynomial regression, two things, and R2 square formula is also available here. The thing is, we should not. We are already going as complex as possible, so we should not take the parameters which will not have that much F score value. Here, I go to the program here. This program you don't write more than once. Why? Because he has been clicking the batch stats one is a file, and I'm appending the file things to it. When you run this file one more time, already some contents will be there, around some 1200 contents will be there. Along with that content, you will scrap one more time and add. So 1200 will now become 2400. But that will not be the problem, except redundancy. But this field is there now. This field will also be added two times. So after 1200 rows, the 1200th row will be this field row. Again, one this is field row are actually strings. These cannot be converted into integers. So when you convert the INNS to integer or HS to integer or AVE or 100 to integer, it becomes a problem. So that is the case. Okay. Now just change the file name, run it once, it will work. Right? For many everybody, this is the same error, right? So for anyone, it will be solved. Right. So since I run here, it will be saved for you also, right? This is the output after polynomial regression. Thank you.